Welcome back, geometry students. We've just done congruence through transformations, right? We had a nice, good summary line at the end highlighted there in blue. Make sure that was in your notebook. In this second video, we're just going to look at congruence in a slightly different way. We're going to look at congruence with sides and angles, and we're going to, focus a little bit more on the tick marks and the placement and all that kind of stuff. So this is going to be a little bit more precise than how we were looking at congruence in the previous video. The same is true. Oops, I wrote Unit 3 instead of 2 there. So for Unit 2, we're talking all about congruent triangles. There are many ways to conclude triangles are congruent. The way we're going to be focusing on here is same kind of idea from the last video. They're congruent if all pairs of corresponding, or matching is like another word to describe that, matching sides and angles are congruent. And remember, congruent's a fancy word for equal. Okay, so all the matching sides and angles have to be the same. That's just like in the previous video, right? How we drew these two triangles. So you really don't have to write it again, but it's good practice, right? Just to kind of rehash it. So we're just restating what we said in the previous video. So let's do some practice with that definition. I'll leave it at the top of the screen. So if triangle QRS is congruent to triangle XYZ, write all three congruent statements for sides and write three congruent statements for the angles. So I'm going to just draw my triangles. So here is triangle QRS and then triangle XYZ. Notice Q is first, X is first. Notice how I'm putting them in the same spot. R is second, Y is second. Notice I'm putting them in the same spot of the triangle, S and Z. So it is really important that your placement matches. So if it's, the bottom left vertice, right, remember the vertexes are these points, right? They have to match. Okay, so if I think about my congruent statements, I know that these two match. So I could say segment QR is congruent to segment XY. Notice I'm going in the same order, right? Bottom to top, so to speak. I know R to S is the same as Y to Z. Segment RS is congruent to segment YZ. Okay, last one I know, bottom. I know segment QS is congruent to segment XZ. Okay, so there are my side statements. I also want to do some angle statements. So I know the top angle is equal to the top angle. For this one, you can just say angle R is congruent to angle Y. And the reason why is because there's no doubt about which angle is R versus Y, right? If this was part of a more complicated diagram and there were more angles that you could see coming from that point, like if you had something like this, right, and I was focusing on this specific angle down here, there's no way to tell if I'm focusing on that angle. If I call it, if this is like point R, I could be talking about the little angle, I could be talking about the bigger angle, I could be talking about just the side. So if it's more complicated, you have to be careful, but for this purpose, we're good to just use the one letter. Angle S is congruent to angle Z. And I'll do one more here. I'm going to say angle Q is congruent to angle X. So those are my three congruent angle statements and my three congruent side statements. For letter B, we're going to be creating a congruent statement and using information to find EF. So notice I've got these two triangles are what I'm kind of looking at for part B. It's a little hard to see. So KGH is congruent to what triangle? So I'm going to kind of do my highlight idea. So K, notice K's got that special angle symbol. I see that over here. So K is going to match with F. So I'm going to put F first. My second letter is G. Seeing G over here, G's got that one tick mark. Seeing the one tick mark here, so I'm going to use letter D. Letter D is going to be my next one. And then last but not least, H. Right? H has the two lines to mark that angle, so I'm going to use letter E. So with this, we want to be careful about the order, right? If I go K to G to H, it's kind of going in the circle this way. I want to do the same thing with my second triangle, and I want to make sure that I'm talking about the right angles, the angles that are the same, right? Angle K is the same size as angle F based on that marking. So we're going to use that information, and we're also going to mark that G to H. So G to H, I'm going to erase these little arrows to have some space. G to H, so that's this side here, is 5x plus 8 long. D to E is 12x minus 26 long. And H to K, oops, sorry about that, is 6x plus 13 long. So I'm assuming that I have to find x first, right? And I'm going to use x to figure out how long E to F is. So I'm going to make a little note. E to F is what I'm looking for. Now, what's really annoying is E to F has no information marking its side. So if I knew, something like E to F was 2x plus 3 long, once I had x, I could plug it in. But how do I find how long E to F is? Well, let's see. I have these 2 tick marks as a clue, and so does this side. So that means EF is the same as side HK, right? They're the same length because they've got 2 tick marks each. So if I can just figure out how long HK is, then I'm good. But in order to find HK, I don't know X. So that's really complicated. So kind of my thought process is it's the same as HK, right? But I need X first. I don't know X. So I need to make an equation that's true. I'm also noticing, I'm going to change the highlight color. I'm noticing that this and this are also marked. They also both have 1 tick mark. So I am allowed to say that 5x plus 8 is the same as 12x minus 26. So notice with this problem, it's kind of hard to decide what to do first. You want to start where you have sides labeled that are equal sides and both have an expression with x. So that's what I was kind of looking for. I was looking for, okay, both of those sides have 1 tick mark each and they have an x label. I'm now going to solve for x. Minus 5x, minus 5x. I want to get them on the right side because there were more x's on the right side. So from that, I'm going to have 7x's. Minus 26 is equal to 8. I want to move all my numbers to the other side. Let's see. Looks like 34 is equal to 7x. And I'm realizing now that those numbers are not working out so nice. So I think there might have been a typo in the problem. I had meant for them to work out nice. So I'm going to change this to a 9. I'm going to make it 5x plus 9. So I'm going to adjust it in my picture. Over here I'm making it 5x plus a 9. I'm going to adjust it here. I'm going to keep the adjustments in a black color so you can see them a little bit more easily. I'm going to make this a 9. So a 9 and a 26 is going to be a 35. And that's divisible by 7. So I had meant it to be something divisible by 7. So sorry about that. X equals 35 divided by 7. So x is equal to 5, right? 5 times 7 is 35. Now that I found x, right, kind of go back to my train of thought. We want to find how long E to F is. E to F has 2 tick marks, so does H to K. So HK is 6 times x, which we know is 5, plus 13. 6 and 5 make 30. 30 and 13 makes 43 units. So H to K is 43 units. So is E to F because those sides have been labeled as congruent. So E to F is 43 units long. We don't have a specific amount of units, so I'm just going to call it units. So what you're seeing here is using the idea of what we know about triangles, which sides are congruent, which angles, we are able to do some algebra solving based on that. And what's really nice is we were able to use the idea that E to F was the same as H to K, and we didn't have to have a label for E to F in order to find how long it was. So that's kind of a nice strategy that we can use. Okay, part C is actually more of an honors level. Based on the equations that it has, it ends up being equations like this, which signify a system of equations. So if you're interested in this, I'm going to leave this until the end. So come back to it at the end if you are interested. These ones, use measurements to determine if the triangles are congruent. This is a good practice problem. I would say this should have been my one of my first practice problems, right? Because it's a lot easier to do. So let's see. We have 65 degrees and 90. I know that triangles add to 180 degrees. That means if I do 180 minus 90, there's 90 left. If I do 90 minus 65, that would be what, 25 degrees? So that's nice. Those kind of match, right? And that can also inform me that this is also 65 degrees, which is super nice. Now, I'm also missing the last side of this triangle. So one strategy I can use, if you've ever heard of it before for right triangle, there's something called the Pythagorean theorem, and it's where you take the smaller two sides, which are these guys, and square them. So 77 squared plus 36 squared equals whatever we're looking for. We normally call it c because we normally do a squared plus b squared is c squared. This is kind of like a little preview. We're going to do more of these ideas later on. So I'm going to use my calculator to do that. I'm going to do 77 squared, which is 77 times 77. 5929 is huge. So that's going to be 5929. I'm going to add that to 36 squared. 36 times 36, 1926. So I'm going to be adding those together. So that's going to add to 5929. It's 5929. And it's 7225. So 7225 is equal to c squared. Let's see if that is a square rootable number. So I'm going to square root it of 7225. And it is. C is equal to 85. Let's double check. Is the other side? Yep, the other side is 85. That means we would be able to conclude that this should also be 77. So it looks like we've got matching sides. Right. Let's double check if the angles are in the right place. So is the 90-degree angle between the yellow and the green for both? Looks good. Is the 25-degree angle, right, this one up here, is it between the yellow and the pink? It looks good. And is the 65 between the pink and the green? Looks good. So we would say yes, matching sides and angles are congruent. And notice we had to be careful about the placement, right? That like the 25-degree angle is between the same colored sides. If you want a quick double check on how you're feeling before, class on Wednesday, here are two good practice problems that are more of like the core straightforward level. And then at the very end, if you are interested in going back to that honors problem, I do have a written solution that I can put at the end of the video. So go ahead and pause the video, try these out, unpause when you're ready to check. So there are those answers right there, right? So the first one is a little tricky because the ordering is a little hard to follow, right? There's the, you want to pay attention to the right tick marks. So it goes blue, pink, green was what I chose. You might have done it in a different order, but it should then go D first, because notice D has the right angle marking. E has the same as B, and F has the same as C. If you did a different order, that's perfectly fine. And then number 4 was like connecting to that Pythagorean theorem that we had just done here. So maybe it was fresh in your mind. This one's a little different though, because with our a squared, b squared equals c squared, notice we're looking for our b, one of our shorter sides. So it ends up being, you have to do 9 plus b squared is 36. Subtract 9 on both sides, and b squared is whatever squared makes 27, which is about 5.2. And it kind of makes sense, like we know 5 squared is 25, and 6 squared is 36, so we know it's somewhere stuck between 5 and 6. Okay, if you were curious about the honors level problem, right, this problem here, feel free to stick around for the next minute. I've got a key written out here. So here is the key of the honors level problem if you were interested. So take a look there. We are using elimination, which is where you have to make the 12s match. One positive, one negative. You add the equations and you get 42x is equal to 336 if you were focusing on the 12s like I was. You get x is equal to 8. From there, following the arrow, you plug it into one of the equations to see that y is 2. Following that, the next arrow leads us to plugging in x and y to find z.